Here we go again. Another BS copyright claim that I have to rectify after a video's been up for over a year. Apparently an image that I got off YouTube now has a claim against it. So here we go. We're going to cut it out. Please rewatch so I can regain my revenue. Thanks. Well, today I was down at one of the local electronics suppliers picking up some parts for another project, and I was going through the surplus bin and I found this CAMS 60 channelized agile modulator, a blondered tongue. This is top quality cable head end type equipment. And I've got a few modulators around here that I do use for my in-house distribution system that I think I've showed you guys in the past. And I've always been on the lookout for stereo modulators. They're as rare as hen's teeth. And I'm looking at this one. It's a channel 12, and it has the optional broadcast television stereo generator built in, BTSC. A little quick trip to the Blonder Tongue website and you will see that this modulator is still available. Limited quantity, so I would imagine it's out of production, as most cable operators are now phasing out their analog distribution and going full digital, but I'm sure that there are probably still some small cable operators or apartment blocks and stuff that have got their own in-house system and they haven't upgraded to digital. Digital is very expensive, but as you can see, as of today, this unit is still available. It's $1,128. Okay, I picked this thing up for a fraction of that. So I was kind of, do I need it? No. But it was one of these units that I've been looking for an MTS modulator for quite a while. I do have one MTS modulator right now. It was one that Radio Shack sold a number of years ago, and it was a channel 3 or 4 modulator, but I was looking for one on a higher, and I want to stick to the VHF band. These UHF ones, when you get the attenuation of your cable and so forth, especially on long runs, the picture tends to get a bit noisy. And the problem with UHF, at least where I am, is that all of our HD over-the-air signals are on UHF. So you have to pick your channels carefully. Otherwise, you can interfere with off-air reception, which I also have running through the same cable. I have off-air reception and my own internally generated signals on the same cable. That way I can go to my TVs in the house and I can bring up the HD broadcast channels as well as bring up my own internal stuff, which is typically coming off of a media player or off of one of my other boxes. Anyway, I haven't even tested this thing out yet, so I don't know if it works, but I'm going to pop the top off this thing and show you guys what this thing's got inside it. A bunch of screws later, the top is ready to come off this thing. And what you'll find in here is everything is compartmentized. So here's what we've got in here. We have our power transformer over here and our rectifier board over here. So our 120 volts comes in, runs through the power transformer, made in China. The unit itself is made in USA, but the power transformer comes from China. A rectifier board over here and regulator. Again, nice linear regulators. Never going to have a problem with that. There's the 12 volt regulator there. A couple of other components in here. Inside the modulator, you're going to have, that's going to be the power amplifier. That's the, and it's channelized, right? This has got the saw filter and everything in it. So this one's got a sticker on it that says channel 12. Another one on the back. It's got the RF input and the 60 dB output over here, which the cabling from here goes over to a tap, which gives the 60 dB output on the back, and it also has another tap that comes off here, and that's going to come back to this minus 20 dB output for testing, to hook up to your monitor for testing. So this is the signal that would be injected into your cable system, and it's adjustable with the RF power. I've taken the screws off this one. This is the frequency converter. So you can see that inside here, I'm just going to move the camera so you can get a look inside it. There's a series of dip switches. And this is where you set your frequency. This is the frequency converter. How it works, and you can change the frequency of this. There's a little chart on top of the filter which tells you what settings to use for the switches for which channel. This one can do channel 7, 8, 9, 10, 11, 12, 13, 23, 24, and 25. That's the band pass of this. But this unit here is going to be set for channel 12, so it's not something that you really want to change because you'll have to retune the amplifier, I'm sure. But that switches are set in here. This is the frequency converter. So how this thing works, over here is the RF modulator. This is the video modulator circuit. This circuit over here, this is going to be the stereo. This is going to be the audio, the MTS Stereo encoder. So this is where all the audio encoding is done. And it's mixed in with the video onto an IF carrier. It's not modulated at the frequency that gets sent out the back. It's on an intermediate frequency. The intermediate frequency gets sent out the back, and then it's brought back in through a loop through. Now if you notice, there's another little plug here, which a little cap that doesn't have anything plugged into it. What that is for is some of these modulators had the emergency broadcast system cutover. So basically the emergency broadcast system that they would activate in the event of a nuclear war, for example, or a tornado or something coming, where they had to interrupt all the channels at once. So the satellite receiver that was receiving that emergency broadcast signal would be, the IF output from the satellite receiver would be connected through a series of splitters and amplifiers into all of the modulators. And there'd be a carrier operated switch installed somewhere in here that when a signal was received, all of the modulators would switch over. They would switch the IF off out from the modulator, and they would cut into the IF coming from the satellite receiver. And basically what would happen in that event is that if there was an announcement that needed to be made, they could interrupt all of the cable stations at once. This would be a cable operator's head end. So if they had 40 analog channels or 60 analog channels, they could have it looped into all of the modulators, and as soon as that signal was received, it would interrupt the video coming from each modulator and insert the video coming off the satellite feed for the message. And then when the message went away, that's why when they did the test of the emergency broadcast system, if you remember the days when they did that, all the channels would go to the emergency broadcast system at the same time on your cable system. When they were running that test, they would all switch over, and it was because it was internal to the modulator. So basically the IF signal comes out from the modulator section here, and it goes back in, goes into the frequency converter where it is converted to the final frequency, goes into the RF amplifier out, and back out the back. So it's actually a pretty clean unit. And if you look at this, the construction quality of these things is just excellent. I mean, look at the quality of the, I see a little bit of corrosion in here. Doesn't that look like, looks like there's a bit of corrosion there, doesn't it? But got a few of those nasty capacitors. I don't see any leakage around them, but that might be a problem at some point. As I say, I don't know if this thing even works. I took a chance on it because it was something I've been keeping my eyes open for. I mean, mono modulators are a dime a dozen. You can get them for free. You can pick them up out of the recycle bin. But I haven't come across any MTS stereo, so I'm hoping this thing's going to work. So let's hook it up and see if it actually does work. As you can see, getting a closer look at the MTS board, it's got adjustments for the composite, modulation adjustment, and here's our PCB MTS, that's our encoder. If you look on the left side of the screen, you'll see an adjustment that says SAP adjust. So I have a feeling that this unit, this one probably doesn't have the second audio program or SAP features on it. It doesn't have that option. But as you can see, the board itself, clearly there's some other adjustments down there, left plus right adjust and mono adjust. There was options here to option this out for SAP as well, for carrying stations that had the second audio program signal. There's not too many stations on our cable systems out here that had SAP. In fact, I can only think of one that ever had SAP, and they had a descriptive video service on it, at the at some times, but there was only one. Maybe I think it was PBS was the only one that had it. This says channel 12. So in the Vancouver area, if I remember correctly, channel 12 was CTV2 in the analog days. So this would have been, if this came from Shaw, which it very likely did, it would have been for the CTV2 station, because that was the network that was carried on, I think it was channel 12. It's been so long. I haven't had cable myself in eons, but I remember, you know, channel 12 used to be one of the CTV stations. Channel 9 was the main CTV station, and channel 12 was the secondary CTV channel. Anyway, let's get the top back on this thing. The cover makes up part of the shielding, so it probably should be on to operate it. So I'm just going to get the 17 screws back in the top here, and then we'll hook this thing up, and I'm getting kind of anxious to see if it actually works. Okay, now the unit's back together, the first thing I need to do is I need to connect an IF loop-through cable that will loop the IF out from the modulator to the IF in on the converter, because the frequency here from the modulator is not going to be one that a TV can receive. It's going to probably be down at 45 megahertz or below. It's going to be in the intermediate frequency range. And that's just how these things work. And then I noticed that my video in is a standard coaxial connector, but my audio is standard RCA for left and right. So I had to make myself up a cable. I got an adapter here, so I just made myself up another cable. And I've got one of these adapters which will adapt from coax to an RCA plug. So we'll put that on. I'll plug it into that adapter. We'll screw that onto the video input. And I'm just going to plug it into the composite audio video output from my Blu-ray player. Yes, they do exist. The older Blu-ray players had component outputs as well as standard definition outputs on them as well, so you can hook them up to any TV. So there's the right and the left plugged in. Let's power to this thing and see if it works. Power cord, plug it in, and I got to hook up the output to the TV. Oh, we can see something's working because I have lights that are flashing on here. Power light's on, stereo light's on, and my overmodulation light is blinking a bit. So let's turn on the TV and see if it works. There we go. There's the output feeding through to my TV. It is in stereo. I can unplug the individual plugs. I'll unplug the right plug now. Stereo goes to the left channel. Let's move it over to the right channel. Yep. I don't know how well that comes through on camera, but you can hear me switching it to the right channel. Left channel. Right channel. And stereo. It actually sounds very good. Besides the sound quality, that picture is, this is not a high definition TV. This is my shop TV, which is a standard definition plasma, and that's usually where I watch the standard definition programming. Is when I'm working here in the workshop, I usually just pick up one of the house cable channels, and it's in standard definition. But yeah, that picture quality off this thing, that's as good as this TV is capable of delivering. I mean, really, it is a fantastic picture for RF. So here's our connectors on the back. You've got the RF output, the loop through, the left and right RCA inputs, video input. Down below it there's a 4.5 megahertz input, and then you've got terminals for the audio. In case the audio is not on an RCA plug, you can actually terminal strip. There's a switch on the back here for stereo and mono, and when I switch that switch, you do definitely hear the sound change. There's mono, you can hear it. stereo. And then there's this other switch here. When you switch that one on, that actually goes to external 4.5. So, for example, if you were modulating an audio signal that had additional subcarriers and you wanted to modulate more than just MTS stereo, the broadcast TV stereo system had multiple audio subcarriers that they could insert. One was the stereo signal for standard TVs. Then there was the SAP channel that was would give you a second language, but there was a third channel called a Q channel that was a professional audio channel that was to be used by broadcast stations for doing talkback or intercom units, IFB and so forth, to the network operators. And if a unit like this was being used downstream and they needed to insert all of the audio that was, say, in a satellite broadcast off of a satellite receiver, and they wanted to carry the full spectrum, they would take the 4.5 megahertz audio output from their satellite receiver and they could pipe it straight into here and send the baseband video in through the video input and send the composite audio, which contained all of the subcarriers, into the external audio input, and then this would modulate it onto the carrier and all the signals. So in addition to the stereo and the SAP, you could have the professional channel, which was typically used for telemetry or as a talkback channel. A lot of times it was used for telemetry, like for the decoders that would bring up the warnings for severe weather and stuff, right? So that's what that is for. Anyway, talked enough about this thing. It works. It was a great find. Hope you enjoyed this one. We'll catch you later.